section 9.3, similar polygons, students will be able to use similar polygons and students will use proportions to find missing links. You're going to see that there's a lot of similarity between this section and previous sections. It goes along with congruent polygons that we covered. It also goes along with dilations. Okay, so first thing, what exactly is a similar polygon or a similar figure? Similar figures or similar polygons. Two polygons who have the same shape, but not necessarily the same size. Okay, so write that down on the definition of similar figures. Two polygons that have the same shape, but not necessarily the same size. So before, when we talked about congruent polygons, they had the same shape and the same size. Similar has the same shape, but not the same size. If you recall in chapter 5 with transformations, all of them had the same shape and size, except for the very last one we talked about, which was dilations. We had to go through and multiply all the coordinates by the same number. Those were similar polygons, the dilations were. Okay, so we've already been doing these. Now you just know the name of them. So that lesson was pretty much preparing us for this lesson. There's two things about similar polygons that you need to know. The first one, and notice it even has the line for you. Corresponding parts of similar polygons. Corresponding angles are congruent. Corresponding angles are congruent. Just like in congruent polygons, in similar polygons, corresponding angles are congruent. Now, here's the difference between similar and congruent. Number 2, corresponding sides are proportional. Corresponding sides are proportional. So sides are no longer congruent, they're proportional. Proportional means if you multiplied one side by 2, you're going to multiply the other side by 2 as well. If you multiply one side by 6, the other side is going to be multiplied by 6.
It's like the butterfly effect. Yeah.
Okay? Now, looking at the right side. It wants us to list all the corresponding angles. Okay? Well, corresponding angles are congruent. So notice angle A is marked congruent to angle D. So we would write down angle A is congruent to angle D. Where it says corresponding angles, A and D are corresponding.
I don't even see a D.
Yeah, neither do I.
On the other triangle.
So angle A is congruent to angle D. A has one mark, D has one mark. Also, angle B is marked congruent to angle E. And angle C is marked congruent to angle F. Okay. Now, the reason why I listed the angles first before the similarity statement is because I'm going to use my angles to write my similarity statement. Okay? Just like with congruent, the first one doesn't matter. Okay? So I could say triangle ABC, I could say triangle BCA, it doesn't matter. For similar, you just do this wiggly line. So you put triangle ABC is similar to triangle. Since I listed A first, then I have to do D. Since B's next, then I have to do E. And since C's last, then F has to be last. So there's my similarity statement. Triangle ABC is similar to triangle DEF. So a lot like congruent, but instead it's similar. Okay, and then the next thing is talking about the ratios of the sides. It says ratios of corresponding sides. The ratios of corresponding sides are all going to be equal. Okay, so whenever I compare the corresponding sides to each other, their ratios are going to be equal. So what that means is, let me rewrite my similarity statement because I don't have it on here. AB corresponds to DE. So if I were to take the length of AB and put it over the length of DE, so that's comparing this length AB to this length DE, it would be the same as or equal to if I were to compare BC to EF.
That's what we did. The BC
Oh,
is
compare.
shorter than EF.
BC over EF. That would also be equal to the ratio of AC over DF. So the ratios, the scale factors. The ratio gives you the scale factor. Okay, make sure we're awake. Okay, so what that means is, let's say that BC is 2, BA is 3, and CA is 4. Okay, and let's say that EF was 4.
Double.
BC corresponds to EF. Okay, so 2 to 4, you would do 2 times 2. So all of these, you would also have to multiply by 2. So to get ED, you would do 3 times 2, which is 6. To get AC, you would do 4 times 2, and get 8.
Wow.
So they're saying that 2 over 4, this, if you put 2 over 4, they're saying that equals the same thing as 3 over 6.
Yes.
They're also saying that that equals 4 over 8. Now looking at them, they don't look the same, do they?
No. That's not the same.
But
But what will they all simplify to? Tell me that. A half.
what does 2/4 simplify to?
1 over 2. Half.
What does 3 over 6 simplify to?
Half.
And 4 over 8?
Half.
They all simplify to the same ratio. That's how you know it's correct.
The ratio.
Now let's do an actual example with math. All of yours, I whited out the third part, the C. So if you ever see something that says, write the proportionality statement, just ignore it. And I wanted to remind you about scale factor. To find your scale factor, it's the ratio of the side lengths. You always do the scratch that out. You always do image divided by pre-image. So it's always the new over the old. Okay, I wanted to remind you that before we did scale factor. We covered this before in chapter 5.
Are we on the teacher model?
All right. It says, in the diagram, triangle RST is similar to triangle XYZ. Part A, find the scale factor from triangle RST to triangle XYZ. Okay, so to do the scale factor, you're comparing the side lengths. Some people make you do all 3 to make sure they're all the same. It already tells me that it's similar, so I'm only going to have you do 1. Okay. To find your scale factor, remember it's the image over the pre-image. To figure out which one's which, how they worded it up here, triangle RST to triangle XYZ, this second one's always going to be your new one. It's always going to be the image. And the first one is always going to be your pre-image. Now, on your image, XYZ, pick any side you want to pick. I'm going to pick XY, which is 12. That number goes on top. Now to figure out the number that goes on bottom, you have to see which side corresponds to XY. Well, if I look at my statement, XY corresponds to RS. And RS is 20. So I put 12 over 20. Now, in your calculator, I would not type in 12 divided by 20 because these calculators don't do fractions. All you have to do is see what number both of these divide by. So I can divide both of these by 4. 12 divided by 4 is 3. 20 divided by 4 is 5. So my scale factor is 3 over 5.
How do you know what to divide it by?
The biggest number that you divide by.
Remember, if you have questions, you need to type them in. And there will be time for you that I will check the questions. And you should not be talking unless you raise your hand. So right now you shouldn't be talking at all. All right, part B says list all pairs of congruent angles. I'm just going to use my similarity statement to do that. R and X are both listed first. So you put angle R is congruent to angle X. S is congruent to Y. So you put angle S is congruent to angle Y. And T would be congruent to angle Z.
What is it? A Z?
Okay. Now, whenever you're doing the scale factor, I picked XY over RS. So I did 12 over 20 and got 3/5. What side does ZY correspond to?
TS.
So if I did 18 over 30, what would that reduce to?
Well, I'll be 3/5.
Well, I can divide them both by what? 6? 18 divided by 6 is 3. 30 divided by
5.
6 is 5. So you get 3/5. What if I did side ZX, the 15? What would I have to put that over?
5.
15 over 25. What does that reduce to? 3/5. So whenever you're finding your scale factor, does it matter which two sides you pick?
No.
No, because you're always going to get the same scale factor. The thing you have to make sure of is that you do the image on top and the pre-image on bottom.
You're always going to get the same scale factor. Now, I just asked that question.
All right, let's try another one. First thing you're going to need to do is fill in these missing side lengths. PQ is 9, QR is 6, and PR is 12. Okay, it says triangle JKL is similar to triangle PQR. Find the scale factor from JKL to PQR and then list all pairs of congruent angles. So, to get your scale factor, you need to write down which one's your pre-image and image. The second one is always going to be the image. The first one's always going to be the pre-image. Because it says you're going from JKL to PQR. So you're starting at JKL and going to PQR. So PQR is the new one. So to find your scale factor, you just pick one of the sides on triangle PQR. What side would you like for me to pick?
PR and JL.
Can we do PR? Okay, so if I do PR here, do I have to do JL? If you pick PR, you have to do JL because PR and JL are corresponding.
Yes.
PR is 12 and JL is 8. So my scale factor is 12 over 8 for those two sides, but I can reduce that. Alexis R, what can I divide both 12 and 8 by?
3.
I can't divide 8 by 3.
4.
4? Okay, what's 12 divided by 4? Say that again.
3.
3. And then what's 8 divided by 4? 2. So my scale factor is 3 over 2.
Easy peasy. So squeezy.
And then part B says list all pairs of congruent angles. Ryland, what's one pair of congruent angles? They're going to be in the same order. So, like, if the first one here goes with the first one here. Yeah, angle P would be congruent to angle J. Adam, what's another pair?
K and Q.
And Owen, what's another pair?
Eleanor.
Alright, does everyone agree with that?
Yes.
Alright. Let's clear this off. The next one you're going to do with your partner. You need to fill in those missing numbers. KJ is 36, JL is 28, and KL is 48. Once you fill in those numbers, turn to your partner, and y'all are going to do A and B together. Maddox needs to move right there, and you and Owen work together. Owen, what did you and your partner get for the scale factor?
4/3.
Do y'all agree with that?
Yeah.
Okay. And in part B, you had to list all the pairs of corresponding angles. Sierra, what did y'all get as the corresponding angles? Do y'all agree with that?
Yeah.
Perfect. All right, let's move on to the next section. It says, finding missing side lengths. You can use proportions to find the missing side lengths. If you look back at the front page, at the very beginning, when I listed out all the ratios of the sides, I said this ratio would equal this ratio would equal this ratio. Well, you can use that to set up a proportion to find your missing side. So let me show you an example.
And couldn't you just multiply that number by the proportion, or whatever, the ratio?
Okay, it says, in the diagram, triangle DEF is similar to triangle MNP. Find the value of X. With these problems, it doesn't matter which one you put on top or bottom. You can do the pre-image on top or the image on top. It does not matter. The only thing that matters is, if I put a side of this triangle on top in the first ratio, the side over here has to be on the bottom on the first and second. So like if I do this over this, my second ratio has to be this one over this one. Okay? So you've got to use the same triangle on top. So if you put triangle DEF on top on the beginning, you have to do it on the second one. So let me show you what I'm talking about. Okay, so find the side that's X. That's this side here, which is EF. And then find the side that EF corresponds with over here. Well, from the similarity statement, EF corresponds to NP. And NP is 30. So my first ratio would be X over 30. And then you would put equals. Then pick either of these two sides. It doesn't matter. Just pick one.
And then.
You can either pick the 15 or you can pick the 20. Okay. I'm going to pick the 20.
Really?
Since it's on the same triangle as X, it also has to go on top. The only thing I have to make sure of is that I have to find the side over here that corresponds to DF. Well, look at the picture. DF corresponds with MP, and MP is 24. So my second ratio would be 20/24.
Equals that you see what we get.
Now that I have my proportion set up, you can solve it by cross multiplying. You do x times 24
Cross multiply, what's that?
equals 30 times 20.
You don't put cross multiply.
X times 24 is 24x equals 30 times 20 is 600. And then to solve for x, you divide both sides by 24. So you do 600 divided by 24. And I believe it's 25. Check my math and make sure that's right.
It's not too hard. That's pretty freaking hard.
25.
The water steps my head away. I don't even, I wouldn't man.
90% of the time.
Dang it.
I'll do my side, maybe.
Alright, let's do another one together.
That's all you do is find X?
In the diagram, triangle TPR is similar to triangle XPZ. Find the length of the altitude segment PS. So in triangles, if they're similar, not only are the sides proportional, but all of their bisectors are also proportional. Like their altitudes would be proportional, their medians would be proportional, their mid segments would be proportional, even their perimeters would be proportional. Okay, so you need to set up a proportion. They want to know what PS is, but I don't want to keep writing PS. What could I put here instead of writing PS since I don't know that side length?
X.
I do know the side link though.
I did
So let's put an X there.
I thought so.
Okay.
You make three.
Now set up your proportion. X represents this altitude, so which number would it correspond with over here?
20.
The 20. So you would do X over 20 equals. Now you could set up your ratio to do this side compared to this side. They didn't give me the whole side. They just gave me TS and SR. Rylan, what would this entire side be? Perfect. How did you get 12? Awesome. And Allison, what would be this side over here? How did you get 16? Okay, so now I've got my scale, I've got my proportion. X over 20 equals 12 over 16. Now you cross multiply. All right, Alexis D, what do you want me to multiply first? X times 16, and X times 16 is 16X equals, Haley, what would I multiply next? And what's 20 times 12?
Would actually be 240.
3,000.
Awesome. All right, what would I do next, Portia? Divide both sides by 16. And Linnea, what's 240 divided by 16? So X equals 15. So the length of PS would be 15.
Dang it, so I really thought it was going to be 10.
So did I.
Me too. You guys are wrong.
You guys are dumb.
Maybe
You
we
guys are,
should do
you
that.
guys are rats.
You're wrong. So.
All right, let's do the next one together. I know it says guided practice, but we're going to do this one together because first thing you have to do is write down these missing side lengths. But I want you to be careful because sometimes, like quadrilaterals, look like they're both on the same thing, but sometimes one of them could be turned. So make sure, like BC is X. Make sure you look at your similarity statement before you set up your proportion and see what side BC corresponds to, which is RS.
Big rats.
So let's set up our proportion. Dylan, where do I start? What do I do? divided by the value of x. So x is BC. So what side does BC correspond to?
RS.
RS. What's the length of RS?
4.
Okay, so you got x and 4. Now just write that as a ratio.
X over 4.
Perfect. And then equals. Now you can pick any side you want to over here. You can either do 12, 10, or 16. Braden, which one you want me to pick?
16.
16, which is BC. What side does it correspond to?
TS, which is 8.
Okay, so 16 over 8. All right, Kenton, tell me what to do first.
You cross that sucker.
Okay, which one you want me to multiply first?
X times
Which is 8x.
8x.
And then what do you want me to do?
4 times 16.
64.
Which is 64.
Gotcha.
Seth, now what do I do?
Now you divide it by 8.
And what's 64 divided by 8?
8. Actually, x equals 8, and that is your correct answer.
Correct.
Good job.
Very good.
Look at the money.
All right, you need to copy the numbers down on this one. The number that's missing is the 35. You see the arrow, but there's no 35 beside it. Who can tell me what are these two segments right here called? The HF and KM? Huh?
Bisector.
Not quite.
That's right.
Close. Seth?
Isn't it a hinge?
No.
No.
That's what we really just said.
I said mid segment.
Then
Not
what would
altitude,
be-
Sierra. Say it.
The median.
They are the medians. It
I'll
goes
jump
from
here.
a
I was
vertex to the midpoint of the opposite.
Would you really?
Mid segments. Mid segments are proportional.
Good.
Fill that in.
Why is the triangle flip?
It wants you to find the length of KM. You're going to do this with your partner. So go ahead and turn your desk to your partner.
Oh.
Work it out together.